Morning students. Today I am going to take a class on turbines. It's a very essential part of an mechanical engineering. Turbines are basically mechanical devices. Hope you all know that turbines are especially employed in order to generate the power. Water turbines, as an example, different types of turbines are available. Steam turbines, as I mentioned in my previous classes, like boilers, and also water turbines. Water turbines are especially employed in a reservoir as a source of water from a higher altitude to the lower altitude. The main objective of the water turbines is to convert the pressure energy of an water into useful mechanical work. As you all know that generator will take the input as a mechanical and give the output as electrical power. Our objective is to produce the electric power. That is what we are going to use the turbines. Hope you are well familiar with the turbines. These are all the main important three turbines which is kept in your syllabus. Water turbines, mainly Pelton, Francis and Pelton turbine. Before going to that, I would like to give a brief introduction about the particular turbine. So turbines are mainly classified into 2 to 3 types. That is, here I have given in my notes. The turbines is basically mechanical devices which usually converts the kinetic energy and potential energy possessed by the water into mechanical work or indirectly power. Hope you all know that water which is stored in a reservoir, it possesses the potential energy, and the water is released from the reservoir, it possesses the kinetic energy. Both these potential and kinetic energy will be utilized for n number of times over its journey till it reaches the sea or ocean. Okay, so mainly the classification of the water turbines is of 4 types. So first one is based on the action of water on the blade. It is mainly of 2 types. One is impulse and another one is reaction turbine. Impulse turbine means, as I give the explanation below here, impulse turbine especially it requires high head and low discharge. Okay. Before going to that, I will just give a definition for a key definitions like head, water head, discharge. Based on the water head also there is a classification. Based on the discharge there is also a classification. Head, nothing but it is the distance between the source of the water where from it is falling until it reaches to the turbines. It is a distance between source of water and the turbines. This is called head, water head. Discharge is nothing but how much amount of water will be discharged through the reservoir or the inlet or the gates. That is called discharge. What you are going to mention the discharge in terms of Q6, TMC, that is what it is discharge. Okay. So in impulse turbine, it usually requires especially it converts all of the pressure energy into the kinetic energy before it was sent into the 1 or 2 nozzle. Okay. It required high pressure. So in order to require high pressure, it requires high water head and low discharge. Reaction turbine, it majorly requires low head but discharge of water is more. Hope you all know that water is falling from a higher altitude means it possesses a higher pressure energy, but amount of water required to possess that high energy is low enough. That is what in almost all the cases it is not possible to get a higher altitude because of the geographical location. We have to use the turbines depending upon the geographical feature of that particular reservoir, whether it is high or low discharge, whether it is high or low water head. Based on that we have to use that. Another one classification is based on its flow. One is tangential flow. Example for this is Pelton. Another one is radial flow. Example for this is Francis. Another one is axial flow. Turbines will be just installed in one particular phase. Water will be discharged on whether it is a tangential or radial or axial. Classification is based on these 3 types. Another one, as I told you, water head. Head is nothing but a distance between the source of water till the turbine, whether it is a high or medium or low. The last one category is based on the discharge, whether it is a low discharge, nothing but a low quantity of water, or medium discharge or high discharge. Example for the low is Pelton, medium is Francis, and high discharge is Kaplan turbine. Okay, so this is all a brief explanation about this and the difference between impulsive and reaction turbine. So now I will move on to the one by one turbine. First of all, I will move on to the very first turbine, nothing but it's a Pelton wheel. This is a diagrammatic representation of the Pelton wheel. So Pelton wheel is mainly consisting of one casing. This is called a Pelton casing. The major part of this is Pelton wheel and this one. These moving blades are nothing but call it as Pelton cups. And this is the inlet of the water. As I told you, the water used here is tangential flow. This is a tangential flow of water, and this one is needle. Needle is especially used in order to increase or decrease the velocity of the water. Hope you all know that decreases in the diameter of the pipe will increases the pressure or velocity of the water. So the needle is used for that particular purpose. Okay, this is a diagrammatic representation. So in simple way, when the water is flowed tangentially over here, the whole of the impulsive force of the particular jet will be made to hit on these moving blades, called it as a Pelton cups, makes the Pelton cups to rotate in the direction of impinge of the jet. Okay, water will be flow over this particular Pelton cups, makes the Pelton to rotate in the direction of the impinge of the jet. Okay. So indirectly I told you this particular Pelton wheel is connected to the input of the generator, where this mechanical rotation will be converted, mechanical work will be converted into electrical with the help of a generator. This is a working principle of Pelton turbine. So how exactly it look like? These are all the Pelton cups that I told you. It is just look like a cups. This is a real image of the Pelton turbine. And this one is a needle, how it can be increases. So usually jet velocity or pressure will be increases by operating it the needle. If you want to see the diagrammatic or animated representation of the Pelton wheel, it was shown here. See that water will be made to impinge on the tangential direction. The turbine is rotated in the direction of the impinge of the jet. Okay. Then it was connected to this particular generator, where the generator usually generates the electrical power. So keep it in your mind, the water which will be released from here, it will be just suspended and it will be flow in an upward canal. Okay, there will be no wastage of water while generating the power in this type of turbines. In this one, any type of a turbine which doesn't consume any water, only they are utilizing the kinetic and the potential energies of the water or the pressure energies of the water to rotate the turbine without wasting of any water. Further, the water will be used for irrigation purpose, drinking, domestic, any kind of that. Only we are utilizing the potential and kinetic energy of the water to generate the power. This is a working principle of Pelton wheel. Explanation will be given in my notes, is just go through it. Another two turbines is there, Kaplan and Francis. I will take it in the next class. For any doubt, please kindly contact me. Thank you.